Okay, so as a part of our intro to word questions, and again, we're going to be doing a lot of word questions today. There's no point in just doing the basic triangles on a textbook because that's not the point of trigonometry. You need to be able to apply it because, as you know, we live in a shape-filled world. If you take a look, everything in this room is either squares or triangles or rectangles, okay? Or possibly some curvatures, but you get what I'm saying. You need to be able to work with triangles. And I'm going to have a little spiel of why we're focusing on triangles after this example. Okay, so the kilometer, we estimated that the angle of elevation is approximately 25 degrees. Okay, welcome. Calculate the horizontal between the two opposite walls of the classroom. I already mentioned using my measuring tape that this is about 760 centimeters. So this is about 760 centimeters. Record the height of your eye level from the floor. I did say I was approximately 180 centimeters. So I don't know, how much do you think I need to shave off the top of my head if I want to get to my eyes? 10 centimeters? 10? Okay. So I'm going to say that up to my eye level, this is going to be 175 minus, sorry, 180 minus 10. I'm going to be about 70 centimeters. So this portion is 170 centimeters. Okay. Using your data, label the diagram below. So I also have this angle to be 25 degrees. As a class, calculate the height of the ceiling. So I'm going to call this portion, I don't want to confuse it with hypotenuse, so I'll call it X. And there it is. This seems a little confusing. This can be a little complicated if you are drawing in a messy way. So if you want to change this into an easier sketch, focus on what your triangle is and draw it again. So look, for me, my triangle would be this dotted line, this dotted line, and I think that's going. If you have to, do it. There's no shame. Here's your triangle. On the left is the realistic image, but on the right is the mathematical interpretation, and that's what you need to focus on. What we're doing right now is a sheet that I took and and if you've been doing, or if you've been keeping up with your practice, your homework, that should look familiar to you. My goal is to get these word questions and try to connect it to what you've done before. And from there, it's up to you. If you still need help with this, then I'm going to push you to find that help through me or find that help through practice, to whatever you need to get there. Okay? So what do? How do you solve for X? Well, Mr. Kim, it's a right angle triangle. And well, Mr. Kim, we can use TOA. Go ahead, Charlie. Yes. I'm going to go one step further and ask you to save yourself some time. Which two sides do you think we're going to use? Right, okay, so we do have this angle. We're going to use the angle for sure. Well, there is the right angle. So actually, out of the three sides, adjacent, opposite, and hypotenuse, which side do we have no information on? That's the hypotenuse. So you know we're not going to be doing anything related to hypotenuse. We're going to be using this side because I have information on it. And we're going to be using this side because that's what we want. And so I am actually only going to focus on the two sides that I need, and I'm going to label them as opposite and this one as adjacent. So see what I mean by saving the time? I don't need hypotenuse. And with your practice, you can make that extra step and be like, you know what, I'm not even gonna label H. It's not important. So what's my relationship? What's my ratio? OA. Yes. We've got it, let's set it up. So TOA, O and A is tangent. Tangent of 25 degrees is equal to opposite over adjacent. And the rest is on you. Someone left a really nice calculator in class, so I earned a new calculator. That's nice. I wonder if they're going to pick it up. If you got it right, I'm going to skip steps and immediately go to x is equal to 354.39 centimeters. Which actually isn't bad. It's actually really close. I think we're almost there. If I remember correctly, the ceiling is actually just under like 375. And that's not bad considering we have to eyeball the angle and not you actually use a clinometer. I'm impressed by it. So, Cameron, what's it?
Wait, are we supposed to do this now with our measurement? Our height?
Huh? Correct. I give you an angle. I give you one side. You should be able to find that other side with the information I give you. Yes. Okay. Sure. I am going to not skip steps then. So full disclosure, everyone, going from here and jumping to here, I was hoping even if you might not be able to do it yet, that you'd be able to understand it from your practice. This is what's happening. I don't like tangent 25 on its own because it doesn't tell me much right now. So I actually solved it. Tangent of 25 is approximately 0.466. Or you could do 466 or 47. The decimal places are very long. Why not? I just rounded to 0.47. Okay. And then someone want to take my spot? Someone want to fill me up? Yep.
You multiply it by both sides by 760.
Right. There's a division of 760. So I have to get rid of this division so that x is all alone. How do I do that? Both sides multiply by 760. And so I get, sorry, this answer wasn't rounded. So using the rounded answer, you would get 357.2. That's it. So from here to here, basically what I did was essentially skip these two steps and went straight for the answer. Yes. So by principles of algebra, right now there's a division of 760, correct? You do the opposite. Whatever you see, you're doing. So if it's the water's too hot, you got to put in cold water, right? Same idea. Whatever you see, do the exact opposite. Sorry, I'll do this here. Come on in. Oh, just that one paper is enough. Yeah, just to fill you in, what we're doing right now is trying to use trigonometry for real life. Take a look at the bottom. You see that? That's our 760. And we actually use trigonometry to calculate the height of our boat. Okay? So it's real. It's not just like you can actually see this map happening. Yes?
What does like our eye level height have to do with the actual calculations. So I don't see it used everywhere.
Oh, I'm not done yet, sorry.
Oh.
Okay. So what we've established here is this is 352.77. So together, therefore, height of ceiling is, add that together, what would that be? 527.27 meters. Okay, maybe I got prematurely excited. That is a little bit big, but that makes sense because I think our angle was a little bit on the larger side. Right? It makes sense. If our angle is big, the length gets bigger. If our angle was small, then the length of the wall will get smaller. But again, let's say this is limited to human error and lack of technology, but this is what the math allows us to do, right? I don't have the height to go to the ceiling and drop a meter string or meter tape, measuring tape from the there. Yes. Coming back. Your best. Any questions? We're going to be seeing a lot of this, and today my goal is to get you to do a lot of word questions, and to extend, I'll probably give you some situations where you have multiple right angle triangles to use. Everything's going to be SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. We'll get so bored with it, you don't even have to study. You just step into a quiz and be like, oh, this is easy. Okay, that's my goal for you. Leanne, I will save this page, right, as a picture, so you can come back to that. Okay, everyone turn the page. We're going to continue on. Here's another example of what angles can do for you. And this is mixed in with some engineering. So a quick terminology thing. Please take a look at the left side picture and be familiar with the idea of angle of elevation and its counterpart, angle of depression. This is what angle of elevation means. In any situation, they will mention things like angle of elevation or angle of depression. It is when you have, from eye level, imagine you have like your arms are sticking out of your eyes, okay? I know that's really weird, but you have like your hands sticking out. If you are lifting your eyes up, you're elevating your eyes. Does that make sense? And so the angle that you make with the laser beams of your eyes is your angle of elevation. Just like this, right? From eye level, why are you tilting up? That's angle of elevation. With me so far? So anytime it mentions angle of elevation, it is from eye level and up. Okay? On the flip side, if it says angle of depression, it's depression of going down. The same thing, but if I am tilting my head downwards, like for example, I'm on the rooftop of the school and I'm looking down at someone walking by, right? That is the angle of depression. The angle that my two arms are making when I do that is the angle of depression. We'll get a chance to see that again, and you'll see it often in word questions. So I think I can mention that and gloss over it. Let's take a look. I'm going to read the question. Eric's car alarm will sound if the car is disturbed. Make sense? Yeah. But did you know it's actually engineered to shut down if the car is being towed? Surprise. Yeah, it sort of makes sense though, right? Do you want a car alarm to be blaring while they're driving down the highway, like to get to a towing center? No, right? So towing at an elevation of more than 15 degrees. Mike's tow truck can lift a bumper no more than 0.88 meters, so 88 centimeters, higher than the bumper's original height above ground. Eric's car has these measurements. The front bumper is 3.6 meters from the rear wheel axle, and the rear bumper is 2.8 meters from the front axle. Which way does the towing company need to lift so that the alarm gets shut off? So the textbook was nice enough to draw us a picture. If we lift from the front, so use the back wheel as my pivot, and my triangle is going to look like this. So the height can only be 0.88, and the hypotenuse is 3.6. If the tow truck uses the butt of the car and lift it up, then the triangle is going to be 0.88. And because the textbook told me about the distance from the bumper to the front wheel, the hypotenuse is going to be 2.8. Which of these successfully lifts above 15 degrees? In other words, which of these will successfully shut off the alarm? That's your task. Can you do it? I'm going to give you a quick 5 minutes to see if you can at least get one, if not both, done. If you can get one, the next one will be very simple because it's the exact same process. My question to you is, please solve for this angle. All right, so with the maybe about 4 minutes that I gave, or 3 minutes rather, that I gave, how far amongst these steps did you get to? Were you able to identify which sides were involved? Sort of. In the first attempt, which side is going to be involved in my calculation? No? Oh, wow, okay, so we have some work to do. I'll go through this once again. My theta is here on the bottom left corner, which means as my reference, I am going to be using this side and this side, which happens to be my opposite and my hypotenuse based on this. So correct. You have to be able to, this is not math, right? This is you identifying, this is thinking for yourself. You have to get there by yourself. So seeing as how the question gives you 0.88 and 3.6, you should be able to identify, okay, those two sides are going to be used for my angle. And because it's opposite and hypotenuse, it's going to be sine is equal to opposite over hypotenuse. So how do you calculate angle? This is from last class. This is from yesterday. What did we do? How do we get rid of, or how do we separate the angle with the sine function? Yes. Yeah, the inverse sine of whatever bracket or whatever ratio I already had. So here I'm going to need my calculator. I'm going to put all that in. Oh, speaking of which, by the way, if you don't like the fractions, I forgot this step. Welcome. 0.88 divided by 3.6. You can technically also put in 0.244444. If possible, put in as many decimal places as you can. But some of you are probably just going to put in 0.24 or whatever. Okay, so let's be consistent, just 2 decimal places. Inverse sine of 0.24 is approximately 13.886, so 13.89 degrees. Does that clear my 15-degree limit? No. Is the alarm gonna blare? Yes. Am I gonna be annoyed? Of course. So this, alarm on. So that's bad. You don't want to do it from the front. Yes?
I got roughly 14.15.
That's probably because you were more consistent than I was. You probably left the 44444. If I did that, I might have gotten what you got. So totally fine. So I'm assuming attempt number 2 is the proper way to do it, but let's continue. Once again, I am going to use this angle, and with reference, these are my two sides. What are those two sides? Opposite hypotenuse. Sine of the angle is going to be opposite over hypotenuse, which of course, if you don't like the fractions, becomes 0.314. You know what? Let's make like Cameron and at least have one more decimal place, 314. Okay? So if sine theta is equal to 0.314, so I'll write it here, sine theta is equal to 0.314, then the angle will equal to inverse of 0.314. Which is 18.30 degrees. Some of you are like, oh, that's pretty cool. You're probably only thinking about it in terms of through the eyes of the tow truck guy, right? But the applications are bigger. Think about the people who designed this car. When they designed this car, they need to make sure the front and back wheels are placed in a way so that if they were towed, that it would clear. So forget the person who's actually towing. Think of the person who's inventing or designing this car. Think of how much math and consideration you have to put in at the same time. So people are asking, where would you use math? Well, it's hard to see unless we get a little more advanced. So stay with me. Okay. So which method will successfully shut off the car alarm? Well, you have to lift from the back. Any questions? Any questions? Yes.
I'm still confused at how you identify which like stuff to use to replace.
Okay, you can always go back. Sure, I can help you out with that. Anyone else want that question answered as well? I was just gonna go up and sort of. Okay, just more than one. Don't be shy about it. It's either it helps or it doesn't. I'll review one more time. I'm gonna clear this. So the answer is attempt number 2. Okay, which method successfully shuts off the car alarm? Method number 2. The rest of the first half of class, I am going to ask you to do these questions. Let me shift over to a whiteboard and do a quick review of when to use what. Do you want one big picture, or Cameron? Do you want one big picture and I show everything, or do you want like separate triangles to show you different scenarios? What do you think helps you? Okay, you know what? Then it might be better to see the differences of each one. So here is one triangle. And then I am going, is this copy and paste in here? Nope. Here is another triangle. Let's pretend they're identical, okay? And here is another triangle. Okay, let's pretend they're all identical, yes? Okay, if I am given this angle, if I'm given this angle, and if I'm given this angle, you automatically know that this is going to be your opposite side, and opposite side. You also know by default, this is going to be your hypotenuse, and hypotenuse. And of course, using Carter's method, the last side that I didn't label, the side that has the right angle and the theta between, is my adjacent. With me so far? Between these three colors, all you're looking for is what numbers are we using or what numbers are what we want. For example, let's pretend I have, let's stay with red. Let's say they gave me this side as 12, and I want the hypotenuse. They gave me adjacent, they want hypotenuse. Do you see how A and H are going to be involved? Which of these three use A and H both? Yes, that means I need to set up the angle with cosine.
So you use the angle that you have in the, or you use the side that you have, the side that you want for the figure that's SOH.
Sure. So I might have made it a bit confusing. Let's pretend that angle is let's pretend that angle is like 40 degrees, right? So then you do cosine of 40 degrees is equal to 12 over x. And you do algebra. Yes, I know x is on the bottom. It's a little annoying. You have to do some rearranging and blah, blah, blah. But that's how you find it. Let's say instead that the angle of 40 degrees gave you the 12 and then they wanted the opposite side. This is adjacent, that is opposite. Which of these three mnemonic code things use O and A? Yeah, so in second situation, I will be using tangent of 40 degrees. That is equal to opposite over adjacent. And you use algebra, get y all alone, and you have the answer.
So you're still, did I get it right the first time? Or you're still using the angle or the side that you want and the side that you have?
Correct.
That's how you use whichever blocks.
Yeah.
Okay.
So in other words, think loosely. Out of the three sides, which side doesn't help you at all, right? The first question, this side has no information. So just ignore it. You're using A and H. In this question, hypotenuse has no relevance to the question. So ignore it. So the third question, I didn't make anything, but you get what I'm saying.
So if that works, if you want to find an angle.
Correct. How about I use the last one, right? Let's pretend, since I didn't do so, let's use that. In the third example, let's pretend I had this length as 10 and this length as 13. What sides are given off of with respect to this theta? Good. Good. Which side uses O and H? So set it up. Sine of an unknown angle is equal to opposite over hypotenuse, and you can solve it.
But that's now given the two sides that we have.
Correct.
So is that the difference between trying to find an angle and trying to find the side?
Yep.
Okay.
That's it. Essentially, what you're doing is you need an angle and you need sides to link together. So out of these three, one angle and sides, one of them will be missing. Solve for it. Any other questions? Okay. Here's what you're going to do. I know it's a little small print, but take a look at the bottom of the sheet that I gave you. Going back to this. Okay, and it's a little bit small print, but I'm wondering if you can, this time, draw your own triangle by doing number 6. If you rip through number 6 and do number 6 and then 7, maybe in the 20 minutes time before we go for a quick break. All right. Try number 6, please. And number 7, if you can. And we'll pick up from there. So we'll try it. Okay. So every question, number 6, A, B, C, D, it is going to have some kind of triangle. Let's see if I could draw it out. Part A. The Eiffel Tower, 68 meters from the base. The angle of elevation to the top is 78 degrees. Let's do it. We've got, let's pretend this is the Eiffel Tower. Okay, that's a terrible Eiffel Tower. Can we do it better? Something like that. Okay, bear with me. From the base, I'm going to pretend it's like right here because I need to use a triangle, right? The angle of elevation is 78 degrees. What is my height? And let's label the height as, again, I don't want to use h because of confusion with hypotenuse. So there it is. I see it's going to be opposite, adjacent. The answer will be tangent 78 degrees equals x over 68. Again, some people might not like that, so you can rewrite that as 4.705. Again, I have upgraded from 2 decimal places to 3 decimal places thanks to Hammer making a point, which is true. X is now equal to 319.94 meters. Pretty tall. Where are these fruit flies coming from? Goodness. That's part A. Part B. The Empire State Building. 267 from the base. The angle of elevation to the top is 55. So again, looks like it's the same thing. Just to make things interesting, I will make my Empire State Building on the left side and create a triangle towards the right. So 267 meters from the base, the angle of elevation is 55. And I'm looking for the height. Once again, it does look like I'm using the opposite with the adjacent. I am using the ratio tangent 55 is equal to opposite over adjacent. It'll be approximately 381.316 meters. Part C and part D are exactly the same. I think they use tangent. So I'm wondering if you can try that on your own. During the remaining few minutes that I have for this period, I do want to just jump into number 7 because I think it will give us no, it doesn't. It's the exact same question. You can try number 7 and make it. Question, yes. Yes. How do you find it if the x is the denominator? Well, this part. How do I know if there's an x here? Or how do I know if there's an x in the fraction? Oh, I didn't actually change the fraction into a decimal. I changed tangent 55. I solved tangent 55 first. So this became 1.428 equals x over 267. I did it. What I did was I got x all alone, and I got rid of a division of 267 by multiplying both sides by 267. So let me use a different color pen. So multiply 267, which means I have to multiply 267. And so this becomes just x. How about I keep the sides consistent? I will draw it as this. Okay, so part C, you figure out the height. Part D, you figure out the height, and you'll be able to rank which one is tallest and which one is shortest. Okay, 7, 8, and 9 are all of a similar cut from the same cloth. I'm going to ask you to practice this and feel very comfortable drawing your own triangles, because in about, I'm going to give you a 20-minute break. When we come back, we're going to go straight into 5.2, which is word questions. More of this, but drawing your own questions, okay? Drawing your own triangles. All right.